introduce myself before going into the session. Myself, Ramesh, as I said, I'm working for Telecom Limited PNG for last 8 years. And prior to that, I worked with British Telecom. And before that, I worked for Saudi Telecom. All these 14 years, I worked in data engineering and data science, and did lot of ML designs and implemented lot of data warehouse projects, and that's it. So let's go into today's session. So today's session, what we are going to discuss is the data engineering for ML system. How we are going to design the ML system. For that, how data engineering is going to be supported. So let's go one by one. Let me walk through you the agenda, what we are going to see today. So first, if you see what is there in the mind and then versus data. So that's the first thing we're going to see. And then second, data engineering, how we're going to see the detail about data engineering, everything, all the concepts in the data engineering. And then we're going to see the batch processing versus stream processing. And then the fourth one we're going to see is the creating training data sets. And then programmatic labeling. And then last one is the weak supervision. Like how minimal we are going to run the ML system with just minimal supervision. So with this introduction, let's dive into this conference. So the first one, if you see, is the mind versus data. So let's see who is going to win. Is it the mind or data? The mind, what it says, like how this side, if you see, it's an intelligent model architectures that look researchers their entire PhD to design. Whereas the other side, if you see, it's a terabytes of data scrapped from the Reddit in a week, like that. Like it could be terabytes of data. So the next one, we're going to see some famous quotes, what they said about the mind and data. So you could see the screen there, data is a profoundly dumb. And then the another quote, it says like huge computation and massive amount of data with simple learning device, incredibly bad learners. Structure allow us to design systems that can learn more from less data. And then the other side, if you see the data, so you can see general methods that leverage computation are ultimately the most effective and by a large margin. Human knowledge approach tends to complicate method in ways that make them less suited to taking advantage of general method of delivering computation. And then another quote says like we don't have better algorithm, we just have more data. Imposing data structures requires us to make certain assumptions which are invariably wrong for at least some portion of the data. And then if you see data is necessary, definitely it's necessary. The debate is whether it's a finite data is sufficient or infinite data. We're just going to measure how is the data necessity. So you see this interesting pyramid. Most of them might be aware of this. So, but let me walk through on this pyramid, how the data science architect. You see the slide. The top bottommost part is where you collect the data, which from the real-time industry, how it interfaces with the third-party systems, and then collect the logs, sensor data. It could be external data. It could be user-generated content. It could be anything. And then next level, you'll be moving the data, moving into reliable data flow, and then create the pipelines, ETL, structured data storage, and then you explore the data. That's what you transform the data, where you get stored it first, and then you transform the data by cleaning it, removing the duplicate. It could be anything. And then later part of the thing, this is where we start our data science starts, our actual work starts, like aggregate the data and then give the labeling the data. So it could be anything like any logic, something like that, and then put some analytics and then metrics it and then aggregate it. Data training, actually basically you will be training yourself how you're going to convert the data in a useful way, and then testing, experimentation, and then writing simple ML algorithms, like how you're going to output the data. So you guys just going to write your algorithms and then just convert it into a AI model. And then the top most thing in the pyramid, if you can see, is the AI deep learning. Like that's where all your data, whichever we collected from the end user, it's going to be a superlative where you're going to convert it to the industry, where you're going to make a decision, and then we're going to